thank you for coming, such a big crowd. We have today a lot to cover, so let's get started. I want to talk about adventures of scaling Prometheus at Vinted. Maybe not adventures, the problems that we have of scaling Prometheus at Vinted, because we had a lot of problems there. Few words about me. My name is Mindaugas Niaura. I'm a site reliability engineer at Vinted, working in observability infrastructure team, and I joined Vinted 5 years ago. An agenda for today is just to talk about our Prometheus scaling journey from my point of view, because I have seen everything, ups and downs, and all the crazy stuff that we tried over these years. So how we should start journey of scaling Prometheus at Vinted? For sure, we need to start with Sensu. Sensu is, if you do not know, some quite popular monitoring system. It's a classical one with agent-based approach. Agent does everything, collects metrics, for example, from server and sends to the backend. And when I joined Vinted 5 years ago, my first task was to shut it down. And because the Prometheus was coming, the decision has been made to use Prometheus at Vinted as a primary monitoring tool. And if you do not know, Prometheus is famous for its pull methods, where some I don't know, server or some actually any HTTP endpoint exposes its metrics, and Prometheus can pull that over the request. You do not need agent anymore. It has its own database structure, alerting functionality, and state-of-the-art service discovery, really easy to integrate in a cloud-native environments. At that time, our infrastructure was very simple. We had only 2 servers which was scraping all the targets at Vinted that we have. We had relatively small servers there, so we decided to use only 2 days retention, and everything was kept on the server. Of course, developers needed to have longer retention of the metrics, and for that, we used this solution. We utilized Prometheus remote write protocol, specifically designed to send metrics over the wire to Victoria metrics server, which implemented remote write receiver. And it was quite cost-effective solution, because servers costed at the time very little money. Of course, we needed to have 2 servers for redundancy, but that's all right. It worked really well, quite well. For alerting, we also deployed alerts to the servers itself, and everything was running inside the server very fast. Query performance, because you can read everything from disks. And we didn't bother running only a single Prometheus server for alerts, because alert management can duplicate all the alerts, no problem with that. But we had problems with a high availability approach, right? We deployed 2 servers just to make sure that we always scrape the metrics. If one server is down, we still had another which was doing all the job. But of course, for the user, it was not all right. We needed to know which server is working at a time. So this brings us to our secret application, which nobody knows about. It's called Proxy. Stands for Prometheus proxy, right? And it does exactly that. It just duplicates all the Prometheus query API responses. And if one server down, user will not notice anything. You just use Proxy to query all the metrics. Really nice application. And for long-term support, right, long-term metrics saving, also Proxy save us a bunch. We just connected everything with Proxy, and in case we run out of space on a single Victoria metric clusters, we just created new one, pointed remote write to the new empty disks, and left that old cluster running only for reads. Proxy still going, project still going very good at the time, still going strong, 1,000 stars as you see. Maybe you can check it, but maybe not in production. I will explain it why later in the slides. So I needed to shut down Sensu by moving all the alerts to Prometheus, and to make alerts, I needed to have a metrics. So what I did, I launched a couple exporters, and we had a problem. First adventure of many to come. The problem was that two Prometheus servers could not handle the load. It was overwhelmed with all the metrics which I created, as well as disk was filling up, and we needed to find some solution pretty soon. And you think that sophisticated open source monitoring system Prometheus will have some scaling support out of box, right? Nope, it doesn't have any. You need to come up with your own solution, I would say. But the idea is simple. As it is pool model, right? You just need to somehow assign targets, the metric targets which you want to scrape to one server or another. But you can do even that in some automatic way using this hash mode approach, which you can see in the slide. What it does, some single Prometheus server discovers all the targets, and basically address string, calculates hash of it, takes 8 bits of that hash, cast it to the integer number, and then you divide by total amount of servers that you have in the cluster. In this example, 3. So what you are left with is some reminder. You can have 3 values when you have 3 shards. So it's 0, 1, and 2, and the next action will just keep, for example, here 1, another server will keep 2, and etc. Easy peasy. And with that, we was able to scale Prometheus server with 2 more instances. Of course, we didn't have all the metrics on single server anymore, but Proxy did the job for us, joined everything together very nicely. Alerting has issues because users were used to have all alerts on all metrics on the server, right? But now they didn't, so we needed to educate that. You may have some metric on different server, so it took some time, but of course we needed to have also some global alerting functionality. And again, our secret glue Proxy save us a day, because it also has built-in alerting engine, which we use to alert globally. Worked really nicely. And with that, I was able to turn off Sensu, and it was really nice day, very happy day. We are fully running with Prometheus at Vinted. But adventures never end, and Kubernetes was coming. More or less, compute team, which is responsible for Kubernetes clusters, was working, moving most of the Vinted workloads to a Kubernetes platform, and we needed to ensure observability. We are basically scrape to have some metrics, of course. And what good SRE engineer will do in that case, it has working solution. You just extend that to the Kubernetes, right? So we did exactly that. We created separate clusters for Kubernetes. We didn't want too much mix metrics from Kubernetes because we're changing a lot, because we have all these kind of deployments happening. We even were allowed to scrape outside of Kubernetes. Prometheus was running on bare metal servers in completely different place, but we were allowed to connect to any of the pods and scrape them. And Proxy again saved us a day. Everything connected was together. Users didn't notice anything. But then problem started, that our long-term solution that we had didn't work good anymore. It started to crash, and we are creating Prometheus, we are creating Victoria Metrics clusters, I think each 2 weeks, not cost-effective anymore, and it was an awful time that we had at the time. Also Proxy, our beloved Proxy. Proxy is a single-person project. which implemented some interesting merge logics of Prometheus API responses. It works well with some occasions. For example, you can calculate a maximum function by sending queries to downstream Prometheus servers, receive the answer, and then check, and then Proxy can check all the maximums from another maximums, and it joining together very nicely. But with others like rate, you need to have all the metrics in one place to account for counter resets and etc. If you even have gaps in the rate function, you will have not correct results. So we had a big problem with Proxy because everything depended on that single guy who created it. And we, of course, needed to find some solution to this problem, to this adventure. And we did some research and found a solution called Thanos. Everybody knows that. It was quite pretty easy solution because at the time, in our team was joined by the Thanos maintainer, which helped us to choose very easily. With Thanos query frontend and Thanos query and Thanos roulette, we do not need it to run prompts anymore. Users can query, make queries, run alerts and rules, whatever we want. Thanos sidecar was efficiently proxying all the Prometheus API responses and uploading metrics data to object storage, which then we can use Thanos stores to query. And in the background, Thanos compactor was spinning up, efficiently optimizing everything on that object storage. Nice approach. Everything was really nice at the time until it wasn't. Again, we faced a couple of problems. Couple, I mean 6. So first problem that we have is unequal Prometheus load. As you remember, that with horizontal sharding approach, with that clever hash mod functionality, we assigned just metrics targets to each of the servers. We did not know about how much each target has metrics in it. And it created hotspots. And when we have a hotspot in that horizontal sharding approach, we always needed to scale Prometheus cluster up, so it was not efficient, and also that scaling was always done manually and error prone. With our high availability approach, when we scrape metrics twice, we get same results from both Prometheus, but Prometheus high availability pairs, but slightly time stamps are different. And if the timestamps are different of a metric, Prometheus treats as a different metric, so no vertical compaction, no deduplication on the object storage. And of course, we need to address elephant in the room with security. We were allowed to scrape Kubernetes pods outside of it, but of course, it was a big security threat, and we needed to do something about that. Also, we had this big time series database blocks and very long restarts. We will not go to the details how Prometheus database works, but you need to know that each 2 hours from Prometheus creates this metric block on the disk. This was quite big at our time, so big that we needed to have special hardware just for compactor to run. And during that 2-hour window, everything was written in Prometheus servers on the memory. And just for redundancy, if a Prometheus server would crash, everything written as well, it's so-called write-ahead log, which when Prometheus starts, it's always taking all the, replying all the changes that it did. So that took 1 hour in our case. Servers was really working hard. So we needed to find again the solution, and solution seems to be Thanos receive, the remote write receiver implementation from Thanos. It has it has built-in replication feature, which we can utilize to not have to scrape targets twice. And then, if with replication, we just copied metrics to another server, just to ensure redundancy. It meant that timestamps was the same, and we could send that data to the object storage for Thanos compactor to work, to deduplicate that, basically delete that replica. Thanos as well had this built-in tenant support. When you will send a special header with a remote write request, and it will create separate database for that specific tenant name which it received. It helped us a lot to reduce that block size, which I mentioning before. And also, it was really good opportunity to use Prometheus agent, as we didn't run. What is Prometheus agent? It's just a simple, same Prometheus server, but without rule evaluation engine and query engine. Its sole purpose is just to scrape some target, right, and send it over remote writes to some destination. And as it didn't need that ruler engine and query engine, it was much more efficient. And at that time also Prometheus just released that, so we were thinking it would be a good idea to use that, as anyhow we are reworking the whole setup. Then we try to address an equal load problem. There is a project called Quas. Probably you do not know nothing about that. It's really basic idea. There is some coordinator service which knows about each target which Prometheus cluster needs to scrape, but it even knows more information about each target. For example, how many each target exposes metrics. And then you can use some simple sidecar approach to manage these Prometheus configurations in the cluster to assign targets more equally without creating any hotspots that we have. However, project was quite abandoned, and we tried to fix some minor bugs and big bugs as well. It didn't it didn't help. So I don't know, we didn't use it a lot. After that, we needed to address, still we needed to address that elephant in the room I'm speaking about, security. We needed to run Prometheus agent on the Kubernetes cluster. The main problem was how to distribute the load in the Prometheus agent, how we can more or less make it equal between them, so we can set limits and etc. What we came up with, what we did, we thought that it's a good idea to limit Prometheus agent scope within single node. To achieve that, we use Prometheus config reloader application from Prometheus operator project, which uses some templates to render Prometheus config. It was so when pod starts, it can render, for example, hostname environment variable in Prometheus configuration to a concrete value, and we can use that to limit Prometheus service discovery, for example. We were this Prometheus configure loader really looked like good idea to reduce Prometheus agent restarts. If we wanted to change Prometheus configuration, we would just change a template, and then everything will be taken care of a Prometheus configure loader. It will change in itself the reload signal without restarting Prometheus agent. We were very afraid about persistence, because we needed to have that write-ahead log persistence to survive inevitable Prometheus agent restarts. So we made, Kubernetes team made another exception. We were allowed to mount some local folder from a Kubernetes host, and Prometheus was using it to write everything in it. Remember, we wanted to set tenant label as a namespace name. maybe you do not remember because I didn't talk about that. With logs, we separated everything using namespace name, because at Vinted we have this we allow teams to be independent, and we have our own separate namespaces where we run applications, and namespace owner is really clear. So we wanted just to do the same as we did with logs, as it works really well. We wanted to do that the same with the metrics. But now we had another problem, right? As on single Kubernetes nodes, there might be pods from different namespaces, and everything will be scraped to single Prometheus agent in the single database. What tenant then we can set? We came up with this solution. We forked Prometheus configure loader and added to the Prometheus configure loader Kubernetes Kube API client, which upon start will query how many namespaces there are running on the node, and what that Prometheus config reloader will do. It will create remote write configs dynamically and send Prometheus agent reload signal. So if what was removed from the node, the remote write configuration will be deleted, and etc. In such way, we could set tenant label really easily, because we know how many namespaces there are running. However, this didn't work. We've seen that Prometheus agent pods before the change was running with 2 gigabytes of memory. After the change, it was using 40 gigabytes, and it's awful. It was awful. It's because of the remote write inefficiency. Prometheus, for each remote write config, it's creating separate database reader, which takes a lot of space. We even created Prometheus issue on the GitHub, and it still this day is not solved. So we were having another adventure, of course. So what we were thinking now, maybe it would be a good idea that Thanos receive will do all the job. Our all metrics from Kubernetes have namespace label, right? So in remote write request, when the metrics are all mixed together, we will send it to Thanos receive. Thanos receive will take a look to the request and distribute the metrics to each tenant using some namespace label values. And again, we were very glad to have Thanos maintainer on the team, which implemented such a crazy feature. And now everything was nice. We were deployed Prometheus on Kubernetes, solved all the issues that we have. Remember, everything was really perfect, but not. We still had some troubles to solve, another journey to take. That Thanos receive hack, which we implemented, was not very efficient, because it required to put all whole requests that are coming to Thanos receive to the memory, marshal it back again to send to downstream Thanos receive servers. We implemented many fixes and many optimizations, and we get that working, but still it was not very efficient. Another problem, a bigger one, was lack of isolation. When single tenant in a Thanos receive cluster is failing writes, we have a big problem. As everything is mixed in one request, in remote write request, the whole request of that remote write will fail, because there is no partial retry functionality within remote write protocol. You either fail whole requests or only whole request, or fully succeed, and we had this partial failures. So we had many incidents when single tenant misbehaving, was causing the whole Thanos receive cluster going down and nobody seeing metrics. We needed to search for solution again, and of course we needed to get to another adventure. And we were thinking what we can do else. We were thinking, what if we will launch each Prometheus agent for each namespace? Because it's our target, right? It would be very easy then to change, to set tenant ID, because we will know for sure that a single namespace Prometheus agent has only metrics from one single namespace. And we try to solve, it looked like really good approach, and we tried to somehow implement it. And we didn't find any tools to do that. So we bite the bullet and wrote our in-house application called Prometheus Manager, which does exactly that. It's orchestrator of the Prometheus agents. It has built-in a Kube API client. When it starts, it queries for all namespaces in the cluster, and then deploys for each namespace Prometheus agent. We also implemented some templating support in it, so we can manage all the clusters, all the deployments for Prometheus Manager from a single repository. And it helped. We had a couple outages, but only single tenants was affected, single teams was affected, which was a nice change. So we deployed Prometheus also not long time ago. I think we finished 2 months ago or something like that, so no big adventures at the moment about Prometheus Manager. Maybe we will have it in the future, I hope not. So just before talk, I checked, and now Prometheus Manager is running on 20 Kubernetes servers, Kubernetes clusters as we have, managing 2,000 Prometheus agent spots. We have also about 50 bare metal Prometheus servers for our other infrastructure. So it was quite an adventure of scaling from 2 servers to this huge amount. So the end of the adventures for now. Thank you for listening, and you're a good crowd. Thank you.